Okay, hello everyone. I understand that a lot of you guys have varying degrees of experience with Rhino and with modeling in general. And I guess this tutorial is gonna, might be a little bit slow for some people that are more experienced. But I really want to just, provide a good foundation for landscape modeling, and share some of the processes that I go through when I'm modeling uh, things or setting up, you know, uh, context models, things like that. And it's important to know that everyone does things differently. This is my way of doing things, and my way is definitely not the best way all the time. I'm still learning, and there's lots of information out there, and I think that the more that you go and seek out the best solution for whatever problem you have, the more successful you'll be instead of just trying to purely stick to what I'm doing. Um, but yeah, without further ado, I think we can get started. And the first thing we're going to get into here is just kind of the basics of Rhino geometry and just a very quick, brief overview of what Rhino creates, um, and why that matters. Okay, so really quick, I just want to go over the basics of Rhino geometry. Um, and I don't want to spend too much time on this. This is something that I think you should really sort of go and do some research on your own, just for the sake of time in this video. But I think it's important to mention that Rhino really has three main object types. You have NURBS, or non-uniform rational B-splines, and you have meshes, and you have subdivisions, or sub-D models. So NURBS are, well, let's draw one. So let's say we make a sphere, right? If we type in sphere, right, and I make my sphere, points on. So these points, so this is a sphere that is, it's NURBS, and it is defined by a bunch of curves that are defined by control points with a degree, or for lack of a better term, like a level of curvature. Now, NURBS tends to be more accurate. It's used a lot in manufacturing, and it's a lot like vector graphics, in a sense that it's defined by mathematical equations that are kind of infinite. They're adaptable. They don't have necessarily like a resolution per se. And they're used to create surfaces and polysurfaces. If we were to take this and make this a mesh, you can see here that, and if I type in points on, the points land right on the mesh. If I pull this, it's very absolute, right? It pulls a very particular point, and it has this very direct control over the surface. Meshes are a bit more primitive of a geometry type. They're used a lot in like 3D art and stuff. And they're generally lighter on your computer, but they tend to behave more like raster images, right? So they have a fixed resolution per se, right? Which is the number of polygons that make up the mesh. So if I were to like mesh this again and I make the polygons less, let's see what happens. And I take, okay, here. So it's the same sphere that's constructed with fewer polygons, and you can see it's kind of a bit more jagged. So really what a mesh is, it's it's a geometry that's defined by points that are used to construct polygons by either triangulating or quadrangulating the points to form faces. That is then used to approximate some kind of geometry. Meshes, sometimes they're great, sometimes they're not. We'll see an example of why they're good for certain things. But really, NURBS is sort of like the gold standard in like architecture and landscape architecture and product design because it's very accurate, it's very clean. There's definitely ways to do NURBS stuff that's messy, and you'll run into a lot of situations where, geometry gets weird. But anyway, so that's just like a basic comparison between these two types of geometry. And lastly, we have subdivision. So if I take this NURBS sphere and I type in 2 sub d, and I do that, and I choose the sub d. Let me get rid of this. Here we have our mesh, we have our NURBS, and we have our subdivision. So sub Ds are basically meshes. If you press tab, you can see the mesh that it's made out of. But then Rhino sort of simulates, in a way, NURBS by, some kind of complex mathematics that is used to sort of translate this rough mesh geometry into something more, curvy and blobbish. So subdivision geometry is similar to meshes in that you can subdivide it. So if I type in subdivide, you can see it sort of increases its resolution. And I can subdivide this. And it subdivides, but doesn't necessarily get any more smooth, right? It just sort of makes more polygons. But in sub D, it kind of understands that more polygons can better approximate a smoother surface. So I'm kind of getting ahead of myself here. Like, we don't really use sub D that much, but it's nice to know that it exists, and there's fun ways to manipulate it. You can sculpt it nicely. If I like select a face, for example, you can just like pull it, and it's used a lot in like automotive design and product design, things where you're designing like objects that are smooth and curvy. But anyway, that's just a basic overview of these 3 things, or these 3 geometry types. Definitely look into this more. It's super important and is really the basis of everything that you do in Rhino. At its most basic level, the way that I see Rhino geometry and the way that Rhino operates is sort of like a reverse graphing calculator. Graphing calculators, typically you input an equation, and then the calculator uses that equation to define some sort of line on a graph. Rhino takes a line, for example, like if I type in like line, right, or line, and I draw a line, it sort of reverse engineers the line. So you draw a line, and Rhino figures out the equation that represents that line, so that it can be represented in space. So, yep, that's that. So I think the next part of this tutorial is going to be really getting into that actual site modeling, starting with the large scale stuff. So the first thing we're going to be doing is just prepping a bunch of geometry in ArcGIS that we will then use as our base line work in our 3D model. Okay, so before we can do anything in Rhino, we need to have some sort of base geometry. Now, this could be an entire video in itself. I'm not going to go into like super big detail into this, but I'm going to sort of just walk you through the process of how I set all this up and how I exported it so I can open it in Rhino. Now, I think Annie told me that George went over some GIS stuff, so I hope this isn't super intimidating. But you know, I think next Monday I'll be around to answer any questions or to help you out with this part. But uh, really, what you're looking for here is just any sort of data that you think will help you in your model, right? So obviously some sort of topographic data, right? Like this entire tutorial is sort of about topography, I guess. Um, for those of you that aren't familiar, Esri has a terrain layer that you can go and export from. This terrain thing, just search terrain. And you can export that raster and generate contours from it. And then you know, smooth the contours a little bit with the smooth line geoprocessing tool. And the New York City Planimetric database has a whole bunch of shape files that include lots of things like the roads and the sidewalks and building footprints. And really all you do is you take that data and you put it into ArcGIS, you open it, and it's going to be big, like it's going to cover the entire city. So you want to create a feature class that is just going to be a clipping boundary. So in this case, I just made a polygon feature class that I use to just clip everything to it. You can see like contours, and I have the sidewalks and the roads. And that just helps to, you know, just keep your model at a reasonable size. This is, I think, covers your entire site. If not, it's got to be pretty close. But anyway, so the one thing, or there's really two things that I want to point out that are really important, incredibly important. The first thing is the most important, and it's projection. It's always projection. Any problem you run into, it's projection. Always. It's always going to be projection. Somehow. At least that's my experience when I was doing this. Because sometimes you'll build this out, you'll bring it into Rhino, you'll go to export to CAD in your geoprocessing window. For those of you that don't know, export to CAD is like yeah, it's very useful. But you'll open it up in Rhino and it'll look crazy. Contours are all distorted. Roads are weirdly 100 feet wide. You know, things don't make sense. And it's because the way that ArcGIS is projecting it in ArcGIS is governed by your map projection. But in Rhino, well, this is also the one I'm using. I find this one works good. But in Rhino, it doesn't care about what your map projection is in ArcGIS because you aren't in ArcGIS. It cares about the actual projection of the actual data. So you need to make sure that in every single layer, right, you go to your properties and you check your projection, and it should always be the projection that is your map projection, the projection that you want, right? Because essentially what a local projection will do is minimize the distortion of the map in that location, right? All maps are kind of fake, right? You can't perfectly flatten out a sphere. Projections get you close. So making sure that all your layers have the same projection means that all of your layers will you know, line up properly and be scaled properly. I had particular trouble with the buildings, roads, and sidewalks, essentially any of the planimetric database data that I brought in. NYC Open Data, just search up planimetric, whatever. I think I said that before, but just to reiterate, it comes in as a projection. It's like WGS 884, which is very common. But it comes in some sort of variation that like ArcGIS doesn't really recognize. So when you try to reproject that, it can't come up with a transformation that will successfully reproject that to your local projection. In this case, FIPS 3101, and the state plane projection. So in that case, what I had to do was I had to redefine the projection to begin with. So I just redefine the projection. You can just type in define projection in geoprocessing. Define projection. And I just reapplied the WGS 84 projection to that layer. And then I reprojected it. So from defined projection, I then went over to project, and then I took that and I then assigned it the output coordinate system being my map coordinate system, the state plane, FIPS 3101, and then it was able to come up with a geographic transformation that would successfully do the transformation. So I'm realizing this is kind of really complicated as I'm talking about it, but just to give you guys a quick visual, if I go to my junk folder here, let's see, if I try to project, for example, this building footprints, right, which was the sort of original file I was working with, you can see that when I try to change the projection to here, it doesn't know what to do. So it says a data transformation is expected, but the parameter is empty. So for some reason, it can't find a way to convert the two. So to get around that, I just go to define projection. I take that same layer that was giving me problems, and I define it as just WGS 1984, essentially the same projection it came in with, and that sort of just resets it. And it makes sure that the geometry stays in the same place because it's the same projection. If you choose a different projection, it might just end up somewhere in the Indian Ocean or anywhere. So that's that. You typically have to do that for anything you get from the planimetric database, at least in my experience. But okay, now that that's over, so big thing, make sure everything that you're going to be exporting to CAD, and just to be extra clear, if we type in export to CAD, you're going to input, all your input features are going to be the things that you're exporting, right? So just make sure that everything that you want to export has the same exact projection, right? So just right click, properties, spatial reference, and make sure this projection is what you want it to be. Now, the second important thing, which is a little bit less important, but it's still pretty important because it's just, it's part of my process. So, and it has to do with the building footprints. So the New York City building footprint layer or model, or rather the 3D buildings model from the New York City planning, whatever, website is kind of bad, in my opinion. It's kind of it's not very clean. It's very heavy. It'll lag out your computer. Sometimes you just want nice, clean, extruded buildings, no problem. You know what I mean? Just basic. So I came up with a way to do that. So what's convenient about the building footprints data that you get from NYC Open Data is that it has two fields that are very important: ground elevation and roof height. So what you want to do is to get it so that when you open this up in Rhino, the building footprints are set to their correct heights, and then you just extrude them down to the ground. Now, in order for them to show up in the correct spot, you need to actually add the ground elevation and the roof height, and make a new field, which is not here. It's in this one. what am I doing? What am I doing? Attribute table. Make a new field, which I've created here, building height plus elevation. All you do is you just click add field. Make sure you set the data type to a double, and then you just use the field calculator to add the two columns. And essentially what that will do is set the building roof height at the correct location, and then you can use a Grasshopper script that I created to extrude them down, and then you have your buildings. Now, and it'll become apparent why I had to add those two when I open up Rhino. Now, the way that you get the building elevated, right, just by doing that doesn't make the buildings move. You actually need to assign the building footprints a z value based on that field. So I believe it's like at, what is it? Feature to 3D by attribute. So you add your feature, which is just the layer, and then your height field. Here, let's do this, right? Let's see if we did that. And then our height field would be, you just click the building height plus elevation that you just created. And then it will give every object a z value. And the way that you can check that is go to properties, elevation, make sure it's set to geometry z values. And if you go to general, no, source, z values, yes. So hopefully that wasn't too confusing. You know, a part of me feels like I should maybe make a separate video on this. But, you know, I'm trying to keep this not to a million, you know, hours long. What's nice about contours, though, just to wrap this up really quick, is that contours already come pre-baked when you make contours from a DEM that you get from the terrain feature, like hosted imagery layer. It inherits the z value, so you don't have to do anything. That will come in at the correct elevations in Rhino. So the next step, if you're following me here, is to then export to CAD, making sure that every layer that you're exporting has the same projection. And then you're going to open that CAD file, that DWG file, with Rhino. And that'll be the next segment of this tutorial. And you know, we'll use that to start building our large-scale model. Okay, so we've exported to CAD, and we're finally at the part of the tutorial where we're modeling, or we're going to start modeling. This is really the part that we've been building up to, and the part that I think you're going to find most useful. Just a disclaimer, this is going to be more of a, you know, it's going to be a tutorial on workflow, you know, how to move from, you know, this CAD file into Rhino, and then from Rhino build something, and then from Rhino into some sort of program like Illustrator or Photoshop where you can render. I'm not really going to be like doing any of the rendering. I mean, maybe I could if I have some time later. But really, like, you know, once you have the line work, and once you have, you know, all the exports that you need, you know, it's up to you then to go and you know, use that how you see fit, right? Whether it's for a diagram, whether it's for a perspective render, whether it's for a section. But I'll show you how to, you know, cut those sections, and then how to bring that into Illustrator and whatnot. And yeah, so this is the CAD file that I just exported from ArcGIS, and we're going to open it. So open with Rhino 8, and here we go. So it'll ask you what units you want. Feet is what I believe my units are in ArcGIS. So we're going to keep that. And here we are. This is typically the point where you realize something went wrong, and then you got to go back and fix something. Um, and Yeah, this is typically like if you can make it here, you're golden. Everything gets easier until it doesn't eventually, as it always does. But okay, so uh, it's problem solving. You gotta like problem solving, right? Uh, so anyway, the first thing we want to do. So for the first thing, we can see that our contours are elevated to their z height, which we'll check their z height in a minute to make sure it's correct. And our buildings are at the correct elevation. So this is the elevation that the roof of that building is at. So then now that we have the building roofs, we can just extrude them down to 0, and it'll just hit, the C plane, which is where the roads and the sidewalks are on right now. Those don't have a Z value; they're just like on the ground, right? So, and the reason why we added those two fields, the elevation and the roof height, was because if we didn't do that, right, like the roof height field in ArcGIS refers to the relative height from the base of the building to the roof. The elevation is a measure of where it sits on the ground. So you need to first like account for elevation, and then from that elevation point, which is basically just wherever it is on this surface, or on the topography. There's no surface here yet. And then you need to add the roof height. So because really we're building up from 0, which is down here. So whatever, that will give you what you need, and your buildings will be at the correct height. So that's incredible. So the next thing we want to do is make sure that, first of all, does the proportions look right? Does the projection look right? Yeah, that looks like it's pretty spot on. Let's check the distance for certain things, right? So line, this road, let's see if this is reasonable. 62 feet. I buy it. What's this? This path? Almost 10 feet. I buy it. And now let's make sure that these are truly 1 foot contours. So what you can do is you can, let's say we choose this contour and we zoom into it. If we type in line and then V, or you might have to use the distance command. I have it set that whenever I draw something, it's kind of like in CAD where I have this little pop-up that shows me the distance. You can turn this on in the settings. Just go in there, mess around with it. Anyway, so we can see that this is now exactly 1 foot apart. So congratulations to me, I guess, and hopefully to you. We've done it, and the next part is going to be turning this into kind of a large-scale site model that you can use to, maybe diagram on top of, or just do, some, maybe like an aerial rendering, maybe. But you kind of have to understand that this isn't going to be like super perfect accurate, right? Because it's so big scale, when you zoom in, right, you'll notice after we create the surface that certain things are going to be a little weird and whatever. And that's why you go in later to the site scale, your intervention scale, and then really sort of construct something more detailed and controlled in that environment. So next up is building the surfaces. So yeah, I'm going to include some Grasshopper scripts and whatnot. So that's next. Okay, so we're going to begin modeling now. So the first thing that you guys should probably do, well, actually, let's back up. The worst thing you could do right now, in my opinion, is try to patch this surface. If you want to crash your computer, let me tell you, that's perfect strategy. Patch will destroy your computer if you do this. If you try to patch these contours. So, early on in this video, I talked about how sometimes mesh is nice. And in this case, for large scale models that are don't have to be super accurate and are more for diagrammatic purposes, meshes I find can work well for topography. Let's get started. Okay, so you want to open up Grasshopper, and there are two scripts or two definitions that I want you guys to make, right? The first one is for the buildings. So you can just pause the video and just put this together. And this is for the contours. So you can do that. These are very simple definitions. Play around with them. Figure out why they work, right? I mean, really for example, this one is doing is just taking all the curves and making a Delaunay mesh with it, and then just remeshing it so it's just a bit smoother and is made of rectangular or square faces. So why is a Delaunay mesh what I'm going with? Well, it's really good at respecting the contours. So there is a surface or a geometry type that civil engineers use a lot in Civil 3D called a tin, which I believe stands for triangulated irregular network, something like that. And they use that for doing their terrain modeling for a number of reasons, but really it's just because it's precise, it's good for doing calculations, and it respects break lines and things like that. Rhino does not support tin. And to be honest, I'm still learning a lot about tin. I only really just started to explore that. But Delaunay mesh is kind of the closest to a tin, I guess, in principle, right, that we can get. It's a triangulated mesh. A tin is it's triangulated, but it's not quite a Delaunay mesh. It's not really a mesh. Now, in the same way that a Delaunay mesh is a mesh. But so what you're going to do is you're going to highlight all of your contours. A quick way to do that is just to go into contours project. Oh, whoops. Your contours, just select your objects, right click curve, and set multiple curves. And if I turn this component on over here, because I have already done this, you can see, don't worry about this for now, this comes later for the smaller scale stuff, and you can see that we have a surface that has been constructed. If I turn on everything, you can start to see how it's sort of sampling each line and sort of taking those points and starting to build a surface with them. And if we bake this, if we just bake the Delaunay mesh, topo, you can see the triangles. Actually, let me bring that back and let's turn this off. You can see the triangulated mesh. And you can see how it is respecting the, or like more or less respecting the contours. It's not perfect. It's not perfect. It's hard to be perfect at this scale, with this technique at least. Like I said earlier in the video, I'm still learning things too. There's probably better ways to do this, and I'm actively searching for better ways. Because I think topography is particularly difficult in Rhino. Landscape in general is just hard to model because it's not really an object. It's like a field. But that's another conversation. But the way that we sort of smooth this out and make this a bit nicer is by remeshing it. So by using quad remesh, we will essentially recalculate this mesh in a cleaner way, using quads instead of triangles. So we can delete this, and we can go here and we can right click, bake, and topo. And now you can see how much cleaner it is. Now, if you wanted to, you don't really need to for this scale, but you could plug this mesh into sub D from mesh, and it will actually smooth it out a little bit more. But I think this is fine for now. So next is the buildings. So same sort of process. You're gonna select all the buildings, building, select objects, and you're gonna curve and set multiple curves. I've already done it, so I'm not gonna do it. So that's how you reference them into Grasshopper. And then let's just turn it all on so you can see what's actually happening here. Okay, so what it's doing is it's finding the center of the curve, and then it's deconstructing that point. So in this case, it's, you know, for, let's take like this building, right? It's this point right there. And it is deconstructing it and then reconstructing it way down here at 0. So using that, we can create a vector that essentially points down. So it's just like there's like an invisible vector that is pointing from the point up here down to the point at 0 that we've created by this process. And then we are using that vector to extrude our polylines down to 0. And then when you extrude them, it'll likely have holes at the top and bottom, so you can just cap the holes. And you can bake this now. Bake and building. Okay. And now we can turn this off. Now we have our buildings. Now we have our buildings, and they're extruded down to 0, but you won't see that. You could probably trim this off, but it doesn't really matter. But maybe it will, you know, depending on what you're trying to do. So anyway, so now you have your buildings set onto the topography, which is really nice. And I guess the last step here is to just project the pathways and the roads onto the surface. So we can actually turn off the contours for now. So we just have our surface, and maybe we can even turn off the buildings line work. Let's go to Arctic to really get a feel for the landscape. So you can actually see, like, you know, where there's like bridges going over, and you can see how the buildings are set into the landscape, and you know, certain things are not super accurate. Like, for example, like this is actually like a big rock
but it looks like it's kind of, you know, blending in, and there's actually a retaining wall here, and, you know, the roads, for example, are not perfectly flat either. See, that's kind of lumpy. All of that, like theoretically, you could just trim this off and then just rebuild this as a flat surface over here. Um, but you know, this is kind of the trade-off with scale, right? Like you go big, you can't always be super accurate. You could, but it would take forever. You'd have to model everything very meticulously. Um, but maybe there's a way. Maybe there's a way. If I discover a way, I'll share it. Um, but this is what I know how to do. So anyway, let's get back to projecting. So we want to project these curves onto this mesh, and you know, what we can do is just, you know, we can just right click and select objects, and we can, well, actually, you know what we should do? We should actually copy these objects. Let's do duplicate layer and objects for the sidewalks, and duplicate layer and objects for the roads, and just take this out of here. Whoops. I'll just put it down here for now. So we can just turn off the original line work, right? We want to like preserve the original line work. And okay, so now we're going to project it. So we can just right click, select objects, and project onto here. And it's projecting. Now you have your roads that are set onto the surface. Now it's just line work, right? To actually make these surfaces, you know, you'd have to sweep them, or you'd have to cut them out of the mesh. There's actually a command for that. It's hold on, I have it written down somewhere because I always forget it. What is it? Split mesh with curve. You have to split the mesh with all these curves if you wanted to sort of like extract the mesh of this pathway. Anyway, let's do the other one. So project onto here. And I just did the same thing by accident, didn't I? Project. Huh. What is going on? Why is this not working? Oh wait, no, I'm an idiot. It did work. It did work. It's just all here. It's all in line work because I have this selected. God damn it. Hold on. I'm sorry. Let's go here. Select objects. Project onto the mesh. Okay. And now we can select these objects, which are the roads. We can project onto the mesh. And there we go. Maybe let's change this to a different color. I don't know. Cyan. And then we can just get rid of all these curves down here. Don't worry about all that. It's just me messing around before. We can just go like this, take all those, and delete. We still have them. They're still here. But they're just off of the new layer. So now we have all of our roads and paths projected onto the surface. And from here, it's kind of like up to you. You know, something that might be cool to do is to, you know, maybe get all the tree locations. There's probably some point shapefile available on NYC Open Data that'll put where the trees are, and then you can, like, you know, when you bring this into Illustrator, you can like put the trees there, or you can just like sort of approximate from like an aerial image or something. Um, you know, let's say I wanted to make a diagram showing maybe just like the location of my intervention, right? Uh, which let's say like hypothetically is going to be like right here. Um, what we can do, for example, is we can make an isometric from this. Northeast maybe. So, right, we have our isometric there. This is annoying. We do want to get rid of that. Or alternatively, what could be nice is well, you know what I forgot, which would be nice, is having that boundary curve. If you could add that to your export, you'd be able to just like build like just a rectangle. You could just extrude that up to like here, or maybe just like use that as like a reference to pull down some lines and then build services out of that. Yeah, give me a second. It's very frozen. It's very frozen. I tried to extrude the mesh, but I think I could duplicate this border. Oh, what is going on? Oh yes. Well, that's our model, everyone. Okay, so let's get rid of that. Oh, let's just not do that. Okay, so don't extrude the mesh. That was a bad idea. See, like it's really just working through these quirks, and just Googling things, looking things up on YouTube. ChatGPT is sometimes helpful. I wonder, dupe border. Oh, okay, nice. So we could duplicate the border. Copy. Oh wait, let's actually not do. Let's put this on its own layer. So border, and let's make it some nice color, maybe like orange. Get on it. Okay, do border. There's some little artifacts here where the mesh kind of got messed up. That's interesting. I don't think it'll be a huge problem, but those are things you want to avoid if you can. Anyway, so let's lock everything else so I can just manipulate this. So we're actually just going to take those and just delete them. And extrude. No. Copy. V. And I don't know, anywhere. I guess we could just take this point or something and copy this down to the ground. And then I think we should just be able to loft between them. Okay. That looks pretty good. So let's go into our rendered view. Okay, cool. So now if we go into, let's say, isometric northeast. Nice, so this looks like kind of like a nice chunk of the site. So what you can do now, what does Arctic do? Okay, let's say we wanted to start working with this in Illustrator, right? What you can do, which I feel like a lot of people probably know, is, well, first unlock everything. Highlight everything in this isometric view and just type in make 2D. Make 2D. Well, first, actually, something really interesting, or actually just very useful, is going to camera and just like saving a named view. So you just like always have this view, right? You could always just, like you can move and you could always just go back to it. So anyway, make 2D, make 2D, make 2D. And you have a couple options here. Mess around with it, but I think this is all we need. Okay, so it will go and it will make 2D. And you know what? That was a mistake because I actually want the contours in this make 2D. Contours. And actually, let's turn off the topography. Maybe? No, let's keep it on. Make 2D. Okay. It's going to process. So this model is actually located like in the real world, like it's geolocated to like where it is on the planet. And the make 2D will actually go and drop it in the origin, so you can just drag it over. And as you can see in top view, we have this cool thing. Now, all these lines here, you can clean this up pretty easily, and really just go through and clean it up and get everything nice and crisp and everything. That's interesting. Yeah, you might just need to play around with it. It's a lot of this is just playing around. So nice. So we have this, and we have our contours and whatnot. And now let's say we want some like shading, right? So we can go here. You know what's interesting, actually? What's actually better, which I'm not necessarily gonna do, but like it's useful to make 2D of like the different things independently. So you can just separate them out into different layers in Illustrator easily. So actually, maybe we'll just do that. Let's just do that, right? Let's delete this. Delete. And let's like do this for real. So, turn some stuff off here. I'll just turn like a lot of this off. Let's turn a lot of it off. Let's just get off this layer. Okay, so let's say delete. Stop. Let's go back to our named view, get that parallel projection, and let's make 2D. Come on. Make 2D. So that will make 2D of those lines. And we can start building this out in Illustrator now. So I'm just going to do this like piece by piece, I guess. So I'm going to go through, export all this, and then I'll come back and Okay, so I did make 2D for all of the line work. You can see it here. We're in top view, so this is actually the 2D line work, not the 3D model. And I also exported some views of the topography and the buildings by just, I just did this, and then I just set it to Arctic and view captured a file, and just save those so we can get some shading and stuff in our drawing. And really the next thing is just to export this. Export selected. Is that what it is? No, I think it's just export. And I'm just gonna throw this on my desktop. And we're gonna save it as an AI Adobe Illustrator. AI, oh, no, wrong one. Adobe Illustrator. And we'll just name it, I don't know, workshop, line work, and we'll save it. Export, viewport boundary. Huh. I haven't done this in a while. I think there was like a setting when I was doing Make 2D where I could have saved like a border, which would have helped us sort of snap everything together. But I think we should be fine. Let me double check. So hypothetically, let's see. If I were to go back to here, shaded, and we can turn this off and that off, and let's just take the topography for example. Right, view capture, no, make 2D. Viewport rectangle, that's what we want. Okay, so I'm just gonna do that. Oh no, I just overwrote a layer. I overwrote the building layer. It's okay, mistakes happen. We're just gonna undo that and make 2D again, and viewport rectangle, and we're just gonna call this rect 2D or 2D rect. Okay. Almost done. Okay, so we can go into top view now. What the heck just happened? We can go and it's ended up way over here. Just drag it over to where we're working. And turn all that off. Now what we can do is we can just use those curves as just a guide just to snap things to. Let's grab that one. And let's just align this. Where is it? Right here? Yeah. And then now we can actually just delete that because it's, okay. So nice, we have this rectangle now. Which makes things very convenient. So, okay. Let's export this, export, and desktop, and what do we call it? Workshop, AI. And okay. So that is exported now, along with all of my view captures. And let's open it up, see what it looks like. When I do the smaller scale stuff, you know, I'll show you like how to like cut sections and whatnot, and you could always apply those techniques to the larger scale. Any minute now. Okay, there she is. Okay, so now we can scale this to whatever. We can scale this up. And there's our line work. And it's separated out into the different layers, right? You have all the stuff. Let me just make this a little bit smaller here. And okay, so just for the hell of it, let's just select everything. Let's just make it all 0.25 and let's make it black, I guess. Oh no. What just happened? Huh. Hold on. 0.25. Black. Just going through and just changing the colors. That's weird. Huh. Stroke. Stroke. Black. That work? Yeah. Okay. Go. Black. And the contours, we can make those black as well. So now, what the heck is this? Whatever. Okay, so now we have our drawing. And you can see everything's nice and organized and everything's selectable. Now what we can do is bring in our view captures. And this is also a refresher for me. I haven't done this in a long time. Let's see. What are these? Oh, it has the glow thing. Should be fine. Okay. So let's bring this in. And this is when the rectangle becomes useful, because you can use the rectangle to match things up perfectly. And we can bring this to the back actually. So now you have some nice shading. And where's the buildings? Buildings. What the? Oh, whoops. Put them on different layers. Okay, so cool. So now you can see that like the buildings are in front of the line work and the topography and whatnot is below it. And that's kind of annoying. Hold on. Yep, this is the challenge. It's getting everything to just work right. This could just be a Photoshop thing where you just like take that out. But we can do that in a minute. So let's go back to our line work here and let's start to just like establish some hierarchy. So let's turn this off, turn that off. And our building outlines, maybe we make this a little thicker, 0.5, bring this above the buildings so it gives you sort of a nice edge. What else? Here we have our contours, which are nice and light. You know, we can even style this a little bit, you know, give it a dash. That's too big. Let's make it like, I don't know, 1, 2. This is pretty heavy, you know, I mean, it's a lot of line work and it's not always perfectly clean line work. You know, that's fine, I guess. I mean, maybe solid's better. But the point is that like you're seeing that, you know, you can sort of start to modify this. What else? What else? What else? Oh my God, it's really struggling. Let's turn on. Come on. Okay. You know, now our roads, I wonder if you could just fill it. No. So that might take some work, you know, like connecting things, refining things so like you can fill them with a color if you wanted. But maybe we can just bump them up in size or something, right? Maybe the roads can be 0.75. So you can see the roads are a little bit thicker, the paths are a little thinner. Maybe we can actually bring this down so it reads a little bit more, right? Interesting. So now what we can do is, like, hypothetically, let's say we wanted to just like highlight where our site is gonna be, right? We can, oh no. Come on. Okay, I'm just gonna draw this and then I'll come back. Okay, so this is not like incredible, but you can see like how you could start to annotate it and whatnot, right? And if we turn on the ground, a second now, right? You have the ground, and this could be fixed a little bit. What we're gonna do actually probably is this. We're gonna turn off the buildings, I think. And well, okay. The point is that like you could go in, Photoshop this out so this like nice edge looks continuous. But like that's the workflow, you know, for getting stuff from building something in Rhino to go and making some sort of visualization in Illustrator. And, you know, from here, you know, just it's your creative freedom. Go and mess around with it. The best way to learn this stuff is to just try stuff. So that's the large scale tutorial. And next, I'm going to be sort of diving into this area here, and I guess designing something, and just for the sake of doing some more modeling. And I'll show you how to like make paths and stuff, make walls, just the basic commands that I use a lot, especially at work, to like model stuff. So, you know, sweep, sweep to, extrude is very common, among other things. So yeah, next up is small scale. Okay, so I'm doing the small scale model in kind of little chunks, and then I'll come and record it and sort of explain what I did. Because this does take a lot of trial and error, and you know, I don't want you to just sit here and just watch me model forever. So I'll just do these little check-ins and then explain. So what I'm thinking of doing is making a path that cuts through a hill and then ends at some sort of terminus that is cantilevered over the landscape. You know, thinking back to some of your projects from mid-review, you know, this idea of like cutting through the land, and, you know, these sort of very basic kind of topographic operations. So yeah, I just figured that would be something nice to model, because it will show me, well, it'll show you how to do like ramps, how to do walls, how to cut up the terrain, and just general like sort of thinking when it comes to how to model. So I am sticking with the site that I chose before, somewhere like over here. So I cut that piece out, and you know, I'm looking for opportunities. So I see that like there's an opportunity to sort of come you know, around here, like off of this path, and sort of wrap around, and then at some point die into the hill, and then come out here. And you know, the first thing is just sort of an exercise in grading. So I mean, is this the best grading plan ever? No, but you can see how you're sort of at grade for a while here, and then all of a sudden, you know, and you're going up and up and up and up, and then at some point, the grade is hitting these retaining walls. That's what this double line is, and the path continues to go up, but at a slower rate. So you're actually sort of cutting into the hill. So in order to realize this in 3D, the first thing that I did was create the actual ramp itself, and also just elevated the contours to be where they're supposed to be here. I haven't trimmed them out yet, but that is kind of what I did. I took them from the ground, put them up, and when I design this in plan, right, and that sort of brings me to an important topic, which is like, I believe that like every good model starts with a good drawing, or at least a drawing that's good enough. I feel like with modeling, you know, there's definitely a skill that you need to develop, where you need to understand sort of like what is good enough. And that just comes from practice. So anyway, so the way that I constructed this ramp was I drew a line on the ground, and then I did the command called array curve. So essentially, you could see it here, kind of, where let's take this for example, right? What I can do is, if I know I want the path to be 8 feet wide and both retaining walls to be 1 foot thick, I have to draw a 10-foot wide line, right? So 10-foot line. And what I can do is I can array this around this curve. And we're still in flat world right now. I'm just projecting this to the C plane, so we're working on, so we're still in flat world. And what we can do is you can array curve, select object to array, and then that's the object I want to array, select the path, and then distance. I know that every one of these lines is going to be like a foot. So I chose like 20 feet between them. So it's like up 1 over 20. And that's why you see distance as 20 there. Press enter. And now what you can do is you can raise each of these up to their actual elevation. So that one's up 1 foot, that one's up 2 feet, 3 feet, 4 feet, 5 feet. And then what you get is something like this. You get each of those lines are now elevated to their actual height. And you can see that the slope is appropriate because it dies into this mound. I don't know if you can really tell, but it dies into the mound and then sort of comes out here. But it starts at grade. And we can do some grading to sort of refine that, which is what I had done here. Now, in order to make a surface from this, I like to either use sweep 2 or using loft. So what you can do is a way to make sort of a guiding curve is I like to use not this tool, but this tool, the interp curve, and then just click the midpoints of each of these, and it will essentially draw a nice line that follows the center of those guiding cross curves. They're essentially contour lines. And it will follow both in the X, Y, and Z direction. So you'll end up with this nice 3D line that you can then offset to either side and then use to sweep, or you can even just loft between things like this, right? Loft or whatever. So that gave me this path in here, right? And then I offset 1 foot from each side and then extruded this retaining wall, which will be trimmed down later. So I will trim this down to be flush with the grade. But for now, since we don't have topography in, it's just sort of in this big wall condition where it's just kind of temporary for now. So I guess I should elaborate on how I actually did this. So what you can do, well, no, all I did was just extrude it. I just took the curves that I had drawn that represent the walls and then extruded them and brought it up to their proper base height here. So the next step for me now is to go and create some topography from these contour lines. And the first step of doing that is to actually trim out the parts that I don't need. So here, I'm just going to make another copy of this here. I have this nice sort of serial modeling situation going on. And yeah, so we want to adjust the grading of the original grading, which is the red, to actually be what I have drawn in blue. So I'll just trim out what I don't need, and then join the curves, and we'll be ready to actually make the topography. So just one for example, right? I can say trim. The cutting object can be the actual contour line that I drew itself. press enter, and then I can just trim away. Well, that didn't work. Sometimes you might need to just see how it does that. Something like that. I can just go and trim away the contour that was reshaped. So now that's our new contour, and then these can then be joined together. I can take this and that and join it all together into one new contour. And I'm going to go up, do the same thing for all of these, and then we'll be ready for the next step. Okay, welcome to the next step. So I have my contours edited to how I want them, and we're ready to make this into a surface. And surface is sort of a key word here, because really when you're working in detail, and like this model is, you know, it's only so detailed, right? Like you could definitely spend hours and hours doing this, right? But I'm just trying to show you like a few tools that you might use in your detail modeling. But you know, when you're modeling in detail, you kind of want to avoid meshes, because meshes are hard to trim and they aren't so nice to manipulate once they're all already made. And they're also kind of like, you know, they have a resolution. So sometimes you may want something to, you know, be like super smooth. And meshes will always sort of have like a little bit of jaggedness. Surfaces are really what you want to use. So in order to do that, we are going to do a couple things. So once again, we're going to be using Grasshopper for the first part of this. Now, let me get rid of this actually, I don't need that. So this is the definition that we're going to be using. It's very similar to the definition that we used earlier, but this time we are, I don't think we need this either. This time we are converting a mesh to a sub D at the end here. And really, I mean, why not just do all this in Rhino, right? And it's because Rhino, well, first of all, Rhino doesn't have, I don't think it has a native tool to make a Delaunay mesh, which is essential in this case to, you know, preserve some level of accuracy. And also, getting used to more of a very basic parametric workflow for topography pays off in the long run, because sometimes when you're sort of experimenting with landforms, it's nice to be able to just move the contours around and have the surface update in real time. So you're sort of like sculpting the surface by moving the contours, and Grasshopper just regenerates that surface. We're not going to be doing that now, but just like something to think about. And it's also beneficial because it allows you to generate surfaces from like more things, right? Like sometimes you might have like a point cloud or DEM or something that you're generating surfaces directly from, or like a network of curves or something. And Grasshopper is generally going to be your friend there. It's just better. So without further ado, let's do this. So the trick here is to get from a mesh to a NURB surface without destroying my computer. This is why it's really important to, especially at this finer scale, to have everything be like super clean. right? The cleaner your geometry, the easier everything's going to be. You won't end up with weird holes in your surfaces or weird areas where there's like a trillion isocurves or whatever. And it just makes working with it much easier. So take your time, right? If you're going to model something, like you're kind of in for a commitment. So like really make sure you have some time to go in and really do a good job. Uh, which, sort of brings me to another point, which is like, you don't always need to model things. But that's kind of a longer conversation. I've done entire projects where I've never 3D modeled anything. Um, you know, you should be able to work in 2D for a lot of things. Uh, but whatever. Let's get to the contours. So just like before, we're going to highlight all of our contours and we're going to apply them or reference them in Grasshopper by setting multiple curves. So if you haven't already, just construct this definition in your Grasshopper window. And, I guess follow along at this point. So just to I guess describe what's happening here is that we're referencing these curves, right? And when you click on it, it like highlights. And what it's doing is it is dividing those curves using a whole bunch of points that I have defined as 5. Like the spacing between them being 5 feet, because my units are in feet. So this will be in feet. So I've divided all of my curves by points that are 5 feet apart to create like a nice, consistent, set of points to work from. Helps a lot. Rhino appreciates that. Then we're going to flatten the tree. This gets into the concept of data and how Grasshopper and Rhino stores data. And really, this is sort of the main thing to understand in Grasshopper. But the point is that we're just trying to make Grasshopper not care about what line the point is on. It's just points. So we're essentially putting all the points into one list instead of putting the points into a list that is sort of categorized by the line it's on. So then that feeds into the mesh component, which creates a triangulation, which then I remesh into quads, which we did before, and then we create this sub D from it. Now, sub D is much easier to create a surface from later because kind of like how we talked about earlier, it occupies like a weird space between meshes and NURBS. So, it's kind of a good step to just avoid any errors later. So we can just go ahead here and we can just bake these sub D. Topography, and then we can turn all this off. And as you can see, we have some pretty nice topography. It's good enough, right? It's not perfect, right? I mean, you can see these lines are kind of not completely following, or rather the surface isn't completely following the lines. But it's good enough for what I'm doing, right? Another way to do this, and I do this at work a lot, honestly, is you can actually like sweep contours. So this can be very useful if like you need to like really nail it. It's gonna look ugly, but typically like you're gonna apply some sort of like vegetation to it or whatever. There's ways. It kind of just dissolves later. And just to demonstrate that, what I'm going to do here is just copy this over. And, you know, this is a perfectly acceptable way to start to create topography, right? So you can just do that, sweep to, first rail, second rail, you can see that. And then the sweep shapes, press enter, and it creates a surface between that. Now, if you notice, it's kind of like folded around itself, and it's not like super clean, and you know, it's actually like all twisted. This happens for a number of reasons, but it typically has to do with like point spacing and the amount of points and the bend radius that it's like trying to go around. And a good way to sort of try to avoid that is by adding slashes. So by adding slashes, you're telling Rhino to like, you know, just like line things up there. See how that just like fixed it? It doesn't always work. You know, there is a limit to this stuff. And in that case, what I would do is do this in segments. And you can see how things can, you know, take a long time at a certain point. But anyway, so I'm gonna like go through here, and I'm gonna do that. And at this point, we're pretty much good. And then you just do that for all of the contours, and you'll end up with a, you know, like a continuous, well, I guess not continuous, it'll be broken up by, you know, by these shapes, but it will be a landscape, right? You will successfully model this. So, but for the purposes of this, I think I'm gonna not do that, but it is something that is totally possible. And the final step here to take this from sub D to NURBS is to just type in 2 NURBS. And if this is nice and clean and a nice, well-constructed sub D, it should play very nice with this command. Sometimes it won't. So we want to, we can delete our input objects. So it's creating the NURBS. And there we go. So this does look like it kind of, for some reason, didn't completely like it. But it's good enough, right? It's pretty clean. And we can always rebuild it too. Or maybe not. Rebuild. Curves, extrusions to rebuild. Oh, it's because this is a poly surface. Okay, so we cannot rebuild this. But we don't need to. We can still trim it and do everything we need to do with it, so this is good for now. So I'm gonna go ahead and do the next step here, which is just kind of putting in that path and cutting out this topography and getting everything kind of nested together. So I'll be right back. Okay, so at this point we have our 2 parts. We have our ramp and our retaining walls. Sorry, let me get rid of these. We'll make those again. And we have our surface, right? So the next step is to cut out the surface where we don't need it, which is inside of here. So there's a number of ways to trim this out. The way that I'm gonna do it is by creating planes or just like one-dimensional surfaces, or whatever, just a surface that is closed, that we can use to define the area that we want to trim out. So what I'll do here, I'll copy this over. Look at that. All right. And we want to get the edges of this, right? So the first thing I'm gonna do actually, let me grab these. See, I'm already getting sloppy. Look at that. That's okay though. But like, those things add up, and it can affect your model. Um, anyway, so we'll do that. And what we're gonna do here is we're gonna explode everything. So explode. And this is a really sort of essential thing, right? How do you get curves from solids or surfaces, right? Like, how do you go the other way? And this is one way to do that. So what we can do here, now that we've exploded everything, let's just get like the top of it. So now we just have the top surfaces of everything. Whoops. And now we can do something called dupe border. And it duplicated all the borders. So we can delete this, delete that, delete not that, delete that, delete that, and now we have these curves. And now this sort of mistake that I made, or just laziness of just not doing this all in one piece, is we're gonna have to deal with that now. So what I'm gonna do is actually explode this again. So none of the curves, so like these curves are separate. And what I'm gonna do here is just delete those, and delete the inside. So now we're just left with the outside, and we can connect these appropriately. So if we come in here, let me just grab that and just make sure it really snaps to that, and then we can type in join. So now this is all one curve. We can do the same thing here. So we can take this, move it. Sorry. Oh my God. And just move it back. just to get it to like really snap to that. Join. And now we have our curves, right? So we can go in and let's just delete these. And let's extrude this to create these planes. That's huge. We don't scale 1D. They don't need to be that big. And what we'll do is we'll close this off. So a simple way to do that is just to grab this tool that allows you to create a surface from 3 or 4 points and just close it off. And now we have our cookie cutter, basically. So what we can do, we can move this over, and we can put this where we need it. We can move this up, and what we can do now is use this as a trimming object. So we can type in trim with it all selected, and then we can trim out the surface. So go in there, click, and let's move this, but let's keep it just in case we need it. And as you can tell, the surface has been trimmed out. That is the ramp down there. And you can see our wall is retaining. And this is going to be kind of a cool experience, right? Like you're sort of going in here and then all of a sudden the walls get huge and scary and whatever, and then you sort of come out here to like some kind of expanse, right? And then you're looking at whatever's over here. So the last thing to do here, or one of the last things, major things here, is to get rid of this like extra wall here. right? We don't need the wall where it doesn't need to be. So, because this sort of ruins our experience, right? Like we want to sort of enter at grade and feel open, and then all of a sudden you sort of descend into the hill, but it's weird because you're actually ascending, you're going up a ramp, but you're going into something. So it's this weird sort of play on, you know, spatial kind of, you know, like where you are in space and where does it feel like you're going, and whatnot. So now instead of using the walls as the trimming object to cut the surface, we'll use the surface as a trimming object to cut the walls. So this could go terribly, but I'm just gonna try to just do it just straight up with just what I have here. So we'll type in trim, select our cutting objects, which will be our surface, and then attempt to just trim that away. Did it work? No. It did not. That's annoying. So how are we going to do this, right? This is the kind of problem that you'll run into constantly. And I got to think about it. I do have to think about it. Because... Well, I guess what we should do actually is this. We actually probably need the untrimmed surface. Let's test it out. So copy this over. We're just going to reference a point that we know exists in the other model, so maybe this corner. We're going to bring it over and put it there. And now maybe we could just do it with this, right? So trim. Let's use the untrimmed surface, and let's cut that. Oh, okay, maybe. So you can see it did trim it away, but you know there could be problems still. So now we can actually delete this, not that. We can delete the surface there, and now okay, cool. So we have essentially what we want, more or less. Now, the one thing I'm seeing here is that these are not capped. I don't know if you could see that, but like this is not like a solid. So, I mean, the one thing you can try is just cap, but it's probably not going to work. Yeah, it doesn't have closed planar loops or whatever. So, a way around that. There's a couple ways around that. One way is using cleaner geometry. We have this, which is pretty nice. So I'm thinking now, what if I delete these faces and I offset surf by 1 foot, which is the thickness of the walls. Click to flip the direction. Maybe if we try to cut this instead, it will not completely freak out. Okay, so let's grab this and put it somewhere that makes sense. And then we'll bring it up. And maybe this will work out better, and this might actually be the wall that we use. Huh. Okay, so let's do the same thing. Let's take our surface, copy, and like this is just live problem solving, and this is just like the essence of 3D modeling. That was not right. Copy. Let's reference this. That should be in the same spot. I think that is good. Yeah. Okay, so let's try to trim this now. So trim with the untrimmed poly surface. And let's trim that, trim that. Does it look nice? We'll see. Hold on, sorry. That. No, doesn't like it. Still didn't work. Right? Or did it? Wait, is that open? I can't tell. Yeah, it is. Cap. Let's type in cap. Let's see if that works. Nope. Okay. So, what do we do now? Well, what you can do is you can sweep. So what we can do here is we can grab our surfaces and we can move it over and we can explode it. And it's kind of funny because oh no, explode. Cannot explode 12 single surfaces. Okay. Okay, we're good. So, there's also times where, like, I'm sure I'll come back to this later and be like, oh, I'm so stupid, I should have done it this other way. And that's just natural with this stuff. It's just gonna happen. So let's take our surfaces and let's duplicate their borders. Do border. Now we can delete the actual reference geometry. What did I just delete? Actual reference geometry. We don't need that. Oh no, what happened? We don't need that. We don't need that, or that, or that, or that. Let's explode it again. Explode. And now we can trim away some of this stuff. We only need the top, right? We don't need this or that. And we can get rid of that and that and that and that. So now we got to go over here and fix this thing again. Right? Mistakes that you make will always come back. Or just like laziness in Rhino will always come back to get you. So that should be fine. I think it's not perfect, but it should be fine. So now we can just do our sweep command. First of all, let's join all this. Oh my god, what the heck? Why isn't this joining? All right, you know what? I'm gonna do this off camera and I'll come back. Okay, so I got it. I just exploded this and duplicated its borders and got the top area and just sweeped them and then just moved them on top of here. So now we have capped surfaces. So that's pretty cool. The next thing that I see here is there's this opening down here that was trimmed away earlier, that would probably be nice to cover. So, okay. Well, what we can do here is we could sweep it. So, I could take this thing, and I can take these lines are probably going to be useful, and that, and we can move this away. And let's see. Why is our camera? Where's like my settings for my camera? Oh, projection parallel. Lens length? Why can't I change my lens length? Perspective. Oh, okay. Now we're in perspective. Okay. So let's go in here and duplicate the border, duplicate all the borders. And we can delete this, delete that, and I think those are already intersecting, which is convenient. Now let's just trim that off, trim that off. Don't need any of that. That, oh, that. And we probably don't need any of this. Trim, trim, trim. Trim, 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 trim. Oh, we're so close. Come on, get away. Just clean this up. Okay, I'm just gonna move this in case there's any artifacts. Okay, we're good. So, I believe, let's explode this again. So we can get this piece out, that piece out, and I believe we only need this inside part. So I can just draw a line like that and sweep to first rail, second rail, and sweep shapes. That looks good. We can move this to our model, which is hard to get to. Okay. Just like that. So that fits perfectly. Can change our layer to be on the same layer. I don't have the greatest layer management right now, but it definitely helps when you do. And nice. This is great. So what we're gonna do now is we're gonna just make a copy. Just, nice, fresh, clean slate. We're just gonna get rid of some of these extra lines here. All right. We honestly don't even really need the contour lines. I mean, it might make for a cool drawing, but for now, I think I'm just gonna. I'm just gonna get rid of them. Select objects, and I'm just gonna deselect all that. Nice. Okay, this is really great. So we've done something cool. So this is still kind of in one dimension world. So we can give this some thickness. Extrude surf. And I don't know, maybe a foot. Change the object layer and That looks pretty good. Why is it not capped? Capped. There you go. Okay, very cool. But this can probably be cooler, right? We could probably like add some coolness to this. So maybe this is actually shaped like this. Polyline. Let's give it so it's just not like a rectangular, just rectangle, right? What we could probably do is make some nice shape like that. That looks pretty nice. Delete that. And we can extrude this maybe back to here. Cool. Cool. So now, change layer. Okay. All right, we're getting somewhere. I guess we can add maybe a railing to this. Which we can do by doing this. Polyline, polyline. There, and there. And we have our curve now. And what we can do is we can offset this maybe 6 inches. And then that will be used as our kind of guide. So let's say we want like a simple railing. Maybe let's copy this vertically to like 4 feet, right? And we can just do pipe, and maybe let's make the diameter like 1 inch or 2 inch, maybe 2 inch. The other one would also be 2 inches. And there we go. You have the top part of the handrail. And something else we can do is maybe add some vertical elements here. So we could pipe, and our diameter can be 1 inch, or rather, let's do 2 inches again, but just keep it simple. And see, okay, we'll fix that. So first, let's array this. We're going to array this object, and we're going to array it around this curve. And maybe let's space them, I don't know, a foot apart. It's fine. Just bear with me here, please. It's fine. So what we can do to make this look a little better is, I kind of hate that so much. I really don't like that. Maybe instead what we do is it's actually like maybe like a solid extrude curve. Maybe it's actually like a glass thing. Yeah. Maybe it's actually made of glass. Let's just go with that. Whoa, where am I? And we could probably explode this and scale this. Scale 1D. So that it kind of goes into here. Right? Somehow. Right? And in that case, we could actually redo this pipe take this curve and just move it over to, I don't know, maybe goes to the end here. Okay. And maybe same thing on this side. Or, man, this is gonna be a long video. Long video. And then we can pipe this 1 inch, 1 inch. That's not what I meant to do. I meant 2 inches. Cancel, cancel, cancel. Dude, come on. Pipe. Maybe, you know what? Let's just go crazy. 3 inches. 3-inch pipe. Okay. Nice. Maybe we'll change this poly surface to be change algebraic layer. And there we have our little lookout thing. This part down here actually like doesn't need to be like, this could just be like the surface actually. But I think it's okay for now. It's like the same material, so it's fine. You know, when it eventually like renders out, if I go into rendered view. Actually that looks terrible. Well, it's probably because the curves are there. Yeah, if the curves were off, I think it would just blend in. Definitely if you render it out. So there we have that. Now, so we can get rid of this, I guess. So now I guess the last thing I want to do here is, you know what? I'm actually going to fix that. I'm just going to sweep it again. I'll be right back. Okay, I'm actually not going to fix it just in the sake of time, but this could just be avoided by, you know, if I were to go back and retrim this out, I would just be careful about this area. But realistically, like, if we render this out, it'll likely just look totally fine. And it'll probably be vegetated anyway. So I guess the next thing is to project these paths up. So we can just do project, and we're going to project onto this. Now we have our paths projected onto there. And we can what is that? And we can just cut the surface out, basically. We can cut the surface out, and then those just will become just a different surface, and you can render it differently. You know, if you're doing this for real, you might also want to like actually grade this and like make it like a nice path like this, right? But for now, I think that we can just trim it out or split. We're going to split this object, and we're going to do it with, you know what we're going to do? Hold on. Let me just make a new layer here. And we're going to get all those, right, deselect that, right, get all the, whoops, deselect all that. And we can deselect that, deselect that. I think we got it, so we can change our object layer. That's not what I meant to do. Change object layer. Now we can easily just select them, so trim, or rather split. split this object with these objects. It might take a minute. And it might also fail like this. All right. What you're gonna have to do is really just extend these past the surface. So it really just gets like a clean cut through. So I'm gonna do that off camera. Okay, so I'm on my last shape that I'm trimming out. I'm just gonna record this just so you can see what I'm doing. So I have project on and I'm just going and just redrawing these lines with some cleaner splines. And I'm just gonna go through and make sure you sort of overlap, right? I think I'm just gonna not do that part because this edge right here we might chop off anyway because it kind of curves a little bit. But for the sake of demonstration, I think I'm just gonna leave that little curved part out and just assume that this is just a path that doesn't meet up with the road here. But you could totally go in and do that. But I'm just trying to get through this because I feel like now that I had the day to like make a video, I'm like much more thorough instead of just flying through in an hour. But I hope it's helpful. Anyway, so let's make this maybe 10 feet. Does that look reasonable? Maybe 8 feet? Why not? So now we can trim it out. Not trim, split. So we can select our surface and then select our cutting objects, which are our lines. And now you can see it had split the geometry there. So I can go and I can change the object layer just so you can see better. And now, you know, we have like some differentiation, right? Now, if you really wanted to, now is the time where like you might want to start adding, for example, like I know this is like a road. I think it's East Drive or West Drive or whatever it is. Like it's like was built for cars. You know, you can go in and like start adding curbs. That's like a nice detail that actually helps a lot with just like the polish. Some of these I'm sure are just like, you know, this might just be like a random path that isn't like doesn't have a curb or anything. I would have to check maps, Google Earth or whatever. But I think we're at a point now where we can start to make some drawings. So let me think here. Okay, so I think this is where I'll leave off in terms of detail. Not super detailed, but you know, for your site, right? Like there's still so much to model, right? Like I did this fairly quickly. I mean, this video is very long, but you know, spend a couple days on it and you can get somewhere, right? So like I know if I was doing this, I mean, you know, like let's go look at Google Earth, right? So also my internet's working again. Let's go, like so happy. Turns out my driver for my network adapter was just totally like messed up. So I had to reinstall that. And everything seems to be fine now. So anyway, it's like open up a new window. And like this is, like this, what you're looking at here is this area. So let me open that up again. Right, like there's so much you can add. You can add the curbs, you can add this little barrier or whatever. You can even start like adding the rocks in. And all of this can be done using a lot of the same commands. It's like, trim, split, sweep 1, sweep 2, extrude, project. Like those are just the very kind of bread and butter commands that you can really do a lot with. So like totally feel free to just like go crazy with it, and build like a cool model. Because honestly, at my job we do it a lot. I am building 3D models of our projects, which they're small enough that like I can build like a model of it, and it's detailed, and we like render it out. I'll actually show you at the end of this video some models and some renders and things that that I've made, and drawings that I've made from 3D models. But yeah, totally keep going. Like road markings too. Like you could make like such a cool model by just refining and refining and refining. So first section, there's a couple different ways you could do this. A good way to like kind of mess around and like experiment with like sections is by using a clipping plane. So if we add a new layer here, also like after I'm done recording this, before I go to like the next step, I'm going to go and organize all these layers. Definitely like have like a period of time where you just go and just organize stuff. But anyway, so let's make a clipping plane, right? So if I type in rectangle, I can draw myself a nice rectangle, make it nice and big, and we can rotate it 90 degrees. That's not 90 degrees. My mouse has been weird lately. Like I don't know. And then we can, well, we can see where we want to cut our section, right? So, well, I guess before that, let's just do the clipping plane. Clipping plane and rectangle corner. Oh, whoops. Make sure vertical. There and there. Now, oh, that's new. That didn't used to be there. So here, right, here you can go and essentially slice through your model, right? And you can see very quickly how powerful this can be, right? That stuff down there, you could always get rid of or whatever. But, you can really experiment with, really visualizing the sectional quality of certain parts of your design very quickly. Models are one of those things where it's like, it's high, like you put in a lot of time, but once it's made, it's like, it's so easy to generate drawings from. Okay, so I've decided that we're gonna make ourselves a section perspective, since models make that really easy. So the first thing we're gonna do is something I've actually never done before, which is take our model here and drop it into our context model. Anyway, so I'm gonna make a rectangle and use that to essentially trim out everything in the model, right? And in this case, it doesn't necessarily have to be perfect because you're not really going to see the seams, you know? In our final render, what is going on? Scale 1D. Why is it? Oh. Because we're going to be taking our section kind of closer to this. You'll see what I mean in a minute. So I'm just kind of doing this roughly. But realistically, for your model, you should really try to do everything as precisely as possible. I'm just trying to get through this in relatively quick, so I'm just going around and doing this. Yeah. Insert control point. Here. Maybe we can actually do something like that. All right, that's close enough, I guess, right? Okay, so copy. Let's take a point where we can reasonably line up. So maybe that edge of that. And let's go over to our big model and place it in there. Where does this actually go? Where am I? Here, let me turn this to rendered. That's close enough. Nice. So now, parallel, let's go here. And this is interesting. Okay. Let's turn this off. And let's trim. Or maybe mesh trim. Oh no. Oh, it did it. Okay, nice. So you can see that, we're not totally aligned, right? But I think it should be okay for what we're doing. Okay, so for the last part of this, we're just gonna make our clipping plane like we did before. And you can pretty much just go in and just cut whatever sections you want. And I think I'm just gonna not go and export this and stuff. It's essentially the same process as what we did before, right? We make 2D. We might want to view capture a file, some views that have in rendered view. And you bring it to Illustrator, you adjust line weights, and so on, right? So, but for a section perspective, which is kind of the last thing that we're going to do right now, something that you want to do is go into front view, or whatever view is on the side of the model that you want. And you can see that for me, front view is the view, I think. Maybe it's this one. Oh, yeah, duh. I'm an idiot. So let's cut this maybe like right here. And in front view, you can see that, this is a parallel projection, but you could go in and change this to perspective. Zoom in, don't like orbit or anything. And now you have kind of a cool perspective where, for example, right, let's say we move over here, right, staying within the edges of where we inserted our models. So like over here it breaks, and over here it breaks, and this can all be avoided, right, with like just spending more time and doing, just more care. But this is sort of a live thing that I'm trying to get done in a day. So, but you can immediately begin to see the potential here, right? So like when you export this, right, all this stuff below the ground can just be black or like a hatch, or maybe you put soil in there, right? You can put people like lying down here on the grass, put trees in, maybe put a sky back there or something, put someone in here, and all of a sudden you have a really cool drawing. And you can even do things, right, where maybe you have like an isometric northeast or something. I don't know, right? Let's say like, you're making like an isometric or an axon or something, and you want to like have like an isometric section, right? So something like this or whatever, right? And you can like show it this way, or maybe the entire site like this, and show maybe where your thing is. And yeah, so this is like super powerful. And I think I'm just gonna end it there. Feel free to like ask me questions and stuff. The absolute last thing I'm gonna do, I keep saying I'm gonna do something last, but is I'm just gonna show you some examples of times I've made section perspectives, and to just show you what is possible. So let's jump into this. And here, we're just going to go onto my super secret website, Cargo. My website's not up right now, but we're just going to browse it in private. So if we go to my work, landscape architecture, and this project, you can see I utilize Rhino models quite a lot, right? So making these isometrics, making these plans, and these are section perspectives that I made using the same method that I just showed you today. These, obviously, I put a lot more time into. I was a lot more delicate with, just modeling and making sure everything was nice, and, I spent a few days on it. And also, this was just a much easier thing to model. It's like a street. You can kind of just make it flat. It's really setting stuff into topography that is difficult. And, it's something I need to work on, and it's something that is really useful to get good at. At work, I definitely do it quite a bit. And sometimes I have to do it in a quick and dirty way, and sometimes I have a couple days and it comes out really nice. But I think that, that pretty much wraps it up. So this is a super long video. I hope you got something out of my ramblings. I really wanted to show you, I guess, my thought process and how I solve problems on the fly. And I hope that you're able to take some stuff that you learned and apply it to your own models. I'm going to be sending Annie a list of resources, some of which will describe all this much better than I can. And those will be great too. There's actually a couple people that are really good at this. There's like two main people on YouTube that are really good at this stuff, and are really good at explaining it, and have much higher production value. So that's it. See you later.